Hello, welcome to Organic Chemistry lecture series. My name is Isioma Ikhile, and today we'll be revising chirality and human projection using the ball and stick model. Yeah. Okay, so these three questions that we're gonna ask you. I would ask you this black ball over here, this carbon right here. Is it chiral? If you said yes, I'm sure, of course it's chiral, you would be correct because it's connected to 4 different groups: the amine group, the hydroxyl group, the ethyl group, and hydrogen. And this black ball over here, if I asked you, is this chiral, and you said no, it's not chiral, then that would be correct because it's connected to 2 hydrogens which are similar. So if you put this in front of the mirror, like this, in front of the mirror, you'd ultimately be seeing the same thing. So this other one, is this chiral? If you said no, it's not chiral, then you would be correct because it's connected to 3 hydrogens which are similar. So if you put this in front of the mirror, you would ultimately be seeing the same thing. So moving on, we've got that out of the way. Now we'll move on to Newman's projection. So if you decide, there are 2 types of Newman's projection. One is if you decided that you want this to be facing backwards and all the rest of it are facing towards you. So that would make it Newman's projection since everything is facing towards you. But everything faces towards you and this one facing behind you. And the second type is when you look from the top and everything is facing upwards and only this one is facing downwards. That'll make it Newman's projection. I want to teach you all how to move the hydrogen to the back so you can assign priority numbers to the different groups attached to the carbon. So before rotating horizontally, because if you rotate it vertically, it would give you a Newman's projection, which as we discussed earlier, but that's not what we're talking about now. So now this amine group is forward, is like in front, and this hydroxyl group is adjacent to, that means it's on the same plane to the hydrogen, and this ethyl group is behind. So when you rotate it horizontally now, after rotating it, now you can see that the hydrogen is at the back. Hydrogen is at the back. The ethyl group is now in front, and the amine group is now adjacent. That means it's on the same plane with the hydroxyl group. So when you rotate it horizontally, each group takes the position of the group next to it. And so, like so. So now, now the position of the hydrogen determines how many turns you need to get it to the back to assign priority numbers.